What's up, YouTube? This is Mr. Sal.
Yeah,
Don't forget to like, subscribe, and comment.
Hello. Yeah, I'm Olivia.
Alright, today we're going over comparing and ordering real numbers.
And I'm Olivia.
Specifically rational type numbers, or irrationals as well. But that will be our objective today as well. So that is what we need to be able to do by the end of class. Now, by comparing and ordering, sometimes we're just ordering them from least to greatest. Sometimes we put a shall get in between, and we say that one is greater than the other. All right? Do not use a calculator for these problems. Any calculations you may need are given in the problems. For example, order the following numbers from leastest to greatestest. All right? Well, what we can do is we can take all of these four numbers right account, and it tells us right there at the top that 8.5 squared is actually 72.25. So the reason I squared that is because if I square everything, then I can compare their squares and determine which one is bigger based on the squares. So for example, 80 squared, this would just be, the square root of 80 squared is just 80. Then we got 8 squared, which is 64. Then we got 9er squared, which is 81. So you see how this is kind of helping us to order these. But then we also got the square root of 62 squared, which is 62. So now that we've squared these, we can compare their squares and determine which one is actually bigger or smaller. So based on this list, we can see that the smallest value that we have is, the 62. So that came from the square root of 62. The next smallest one was the 64, which came from the 8. The next smallest was that 72.25, which came from 8.5. The next smallest one came from the square root of 80, it gave us 80. And then finally, the biggest one, the greatest in this list, would be the 81, which came from the 9er. So this would be the list from leastest to greatestest. So number 2 here, it says order from least to greatest again. And they've told us what 3.5 squared is. So that, by the way, is usually a good hint to square all of these. Now we need to remember these are in the negatives. So when I square it, even though it would give me a positive, I'm going to keep it negative so I can compare them straight across. First, let's acknowledge that 3.5 squared would have given us 12, that's an arrow, 12.25, and that would have been negative. Alright, so the negative square root of 13, if we squared the square root of 13, that would give us negative 13.
What?
Alright, if we took that 3 and squared it, it would be 9, but again it's negative.
Negative 16.
And then 4 squared would be 16, but again we keep... Oh, thanks. Alright, in any case.
But you will look more useful if you let your afro be free.
Alright, so yeah, that's true. The negatives here are going to make the bigger negatives the leastest. So we do need to start with the leastest, the biggest negative there, which is negative 16, which came from negative 4. So we can check that one off.
Negative 6.
The next smallest one is the negative 13, which came from the negative square root of 13. So that's next on our list. And then the next biggest negative would be the negative 12.25, which came from the 3.5.
I did the same thing too.
It's okay.
Same thing twice.
The negative 9 came from the negative 3. That's our biggest, or our least negative number. So yeah, this would be the list in order from leastest to greatestest. Here's the following calculations to answer the questions below. Put the following numbers in orders from leastest to greatestest. And they told us And they're squaring all this stuff for us, which was extremely generous. So 2.2 squared, that's 4.84 squared. The side length of a square with an area of 4, that would give us a value of 2. The square root of 5, that would be, if we squared it, it would be 5. And also the 2, right? If we squared that, then it would be 4. I mean, we could just use that value, that's fine. And then 5 halves, that's 2.5 squared. Seems like we did that one already. In any case, all right, if you squared that, you'd get 5 times 5, which is 25, and 2 times 2 is 4. 25 divided by 4 is 6.25. So by squaring that, you should get 6.25. You can keep the fraction if you want, but listing these from leastest to greatestest. Oh yeah, let me show that then. I'll show all of it. So for example, you got 5 halves times 5 halves, that'd be 5 halves squared.
Yeah.
5 times 5 is 25, 2 times 2 is 4, 25 fourths. 25 divided by 4, 6.25. So that's where that decimal value came right here. Alright, now that we have that, the smallest value that we have that is squared is the side length of a square with an area of 4. So that's our smallest value. The next smallest value is that 4.84, which came from 2.2. The next smallest value is that 5, which came from the square root of 5. And then the biggest value there is the 6.25, which came from the 5 half. And this would be the list in order from leastest to greatestest. B on 3, find a number between 2.2 and the square root of 5.
4.98.
So let's look real quick, right? When we squared those, 2.2 squared was 4.84. And the square root of 5 squared was 5. So what's the number between 4.84 and 5? Yeah.
4.98.
All right, let's use 4.98. Now that's the squared value. So we actually need to square root that action. And that would give us a value between 2.2 and the square root of 5. If we were using calculators, we would want to figure out approximately what that value is. We could use the list up here as well. See how 2.23 squared is 4.9729? That means we could have also just have used that value. 2.23 would have worked, because this value is between 4.84 and 5. Find an irrational number that is smaller than all of the numbers in part A. So the smallest number in there that we had was 2. What's a number that is irrational that is less than 2? 2 cubed is bigger than 2.
I know.
1.5 is rational. Yeah?
Square root of 2.
That works. If you take the square root of 2, you get something smaller than 2. That is irrational. You could have also have used
Square root of negative 2?
square root of 3. Square root of negative 2 is not real.
Yeah, so isn't it?
Use the following calculations to answer these questions below. Alright, use the following calculations to answer these. Order these numbers from least to greatest. So again, we're going to square these. Alright, so if we squared the square root of 50, that would give us, well, 50. 6 squared is 36. 7 squared is 49er. And 6.5 squared above, that gave us 42.25. And then the square root of 42 squared is simply 42. So the smallest number in this list is 36, which came from the 6.
I already did this thing.
So we use that one up. The next smallest number I got is that 42, which came from the square root of 42. So we use that one. The next smallest is 42.25, which came from 6.5. Alright, so we did use that one. The next biggest number is 49, which came from 7. Bam. And the biggest number right here is 50, which came from the square root of 50. There's our list from leastest to greatestest. Find a rational number that is smaller than all the numbers in part A. The smallest number we have is 6. So what would be, this is a rational number smaller than 6? 1.5 works. What else?
5!
5.
4 squared.
Square root of 16. 4 squared is bigger.
Wait, what's that?
You could use 4.
4 square rooted, sorry.
Very good. Square root of 4. Yeah, anything like that, even something like negative, I don't know, 8 would work.
80!
Alright, find an irrational number that is smaller than all the numbers. Oh yeah, so this is smaller than all those in part A. Such as
Square root of 5.
square root of 5.
Pi squared.
Pi squared?
Yeah.
Well, I would just
Pi.
go with pi.
is 9 something.
Yeah, the square root of pi would work.
Yeah, the square root of 5.
Yeah, something like this. You could just say any negative square root of a non-perfect square, like 2.
Squared is like...
That would work. Part D, find a number between the square root of 42 and 6.5. So it just says a number, it doesn't have to be rational or irrational. But if we squared these, square root of 42 squared is 42. The square root of 6.5, I'm sorry, the square of 6.5 is, we can see at the top there, 42.25. So what's a number between 42 and 42.25?
42.1.
That sounds good. 42.1, 42.15, and then we just square root that action. Done. Here's the following calculations to answer these questions. Again, we're just listing these from leastest to greatestest. So the side length of a square with an area of 9, square root of 6, 2.44. 2.4 repeating, and 2.5. Alright. Well. Alright, well, I guess we'll have to list these. So, let's square all of them. Square root of 6 squared is 6. 2.44 squared is that 5.9536. 2.4 repeating squared. We're going to have to look at that one here in a moment. But let's look at 2.5 squared first, which we already identified as 6.25. And the side length of a square with an area of a 9, that just means that if it were squared, it would be 9. The side length squared is the area. 2.4 repeating, I'm going to leave it as it is, and we'll come back to it. Here's the nice thing about that 2.4 repeating. We know it's bigger than 2.44, but it's less than 2.5. Yeah, so yeah, we are using a lot of logic on this one. 2.45 is just a little bit more than 6. This one's less than that, so it's got to be less than the square root of 6 as well. And we already see that it's less than 6, so it's got to be less than 6.25 and less than 9. So, it appears that the smallest number then would have to come from that 5.9636, 9536. That's a 5. So, that would be 2.44. The next smallest then would be 2.4 repeating. And the next smallest then would be the square root of 6. And the next smallest came from the 2.5. And then finally the biggest number is a square.
That's a lot bigger.
Yeah, this area
never mind.
is already 9, so the side length is 3, which is bigger than 2.5.
Okay.
There's our list from leastest to greatestest. Now, yeah, that one we had to use a lot of logic, actually. So be careful on those, because if the 2.4 repeating, I mean, yeah, we could change it into a fraction, but that's going to be a huge pain. So if we can just see that it's bigger, but it's bigger than 2.44, but it's also smaller than 2.45, then we should be good. Find an irrational number that is between 0 and the smallest number from part A. The smallest number from part A is 2.44. So an irrational number smaller than that, something like the square root of 2.
I said that.
That's good. Or the negative square root of 3. Or the square root of pi. Any of these would work. Yeah, you can't put 5.9 repeating because that actually is just 6. You don't have to understand that right now. The rule of 9s helps us though. These would be the 4 easiest answers. I mean, it only asks for 1, but there's 4. Use approximations of pi on, let's just show us below there.
I don't like those.
And answer the questions below. Alright, here we go.
You didn't give me any chances to.
Alright, use the approximations. We got these. We know pi is between 3 and 4. Pi is between 3.1 and 3.2. It's between 3.14 and 3.15. And it's also between 3.141 and 3.142. So as it turns out, these top 3 are very general estimations. The farther down we go, the more accurate it's becoming. But we can also see here that 3.15 squared is 9.9225. So when it asks to find a number between 3 and pi, if pi is between 3.141 and 3.142, that means that 3.141 has to be between 3 and pi as well. Alright, so a more general answer for this would be something like 3.1.
Is there any other number like pi?
3.1 would work.
Yeah, it's.
3.1 is less than 3.14, but is also greater than 3. 3.1, because it's 3.14, you could do 3.09, something like that. Okay.
With the square root, I've done forever.
Find a number that's between 3.14 and pi.
3.141.
3.140.
That would work. 3.141 would be correct.
No.
Ha ha.
Because it's between 3.14 and 3.1415.
I thought it was 3.1.
We could show a 0 there to show that as well. Which is larger and why? Pi plus 5 or 8?
Pi plus 5.
Well, pi, what is the approximate value of pi?
3.1.
3.14. So if I added that to 5, then I would get something like 8.14 right here. Compared to 8, well, that means that the pi plus 5 is bigger. Which is larger and why? Well, 10 minus pi would be like 10 minus 3.14, which would be something like 6.86.
Oh.
Wait, is there computers
And 7.
programmed to find the end of pi?
So that means that 7 is bigger. Alright, which is larger, 2 pi or 6.2? 2 pi is why?
Oh yeah, 2 pi.
Well, pi is 3.14-ish. If you multiply that by 2,
6.28.
you get something like 6.28.
Wait. I just
Alright,
said
good.
that, Gavin.
So pi squared was 9.898,
Oh wait, I got it.
which is, in comparison to 10, it's smaller. So yep, 10 is the bigger number here.